Experiment 1, recrystallization and melting points, we're going to begin taking a look at purification techniques. Some common purification techniques used in this lab are recrystallization, extraction, chromatography, and distillation. These are all physical processes which allow us to obtain a clean and pure product. In this lab, we're taking contaminated benzoic acid, which is composed of benzoic acid and copper sulfate, and we are dissolving it in a minimal amount of water slowly at a heat of 95 degrees Celsius. After the contaminated benzoic acid has dissolved, we slowly cool it to room temperature. After it's been cooled to room temperature, we cool it in an ice water bath and isolate our product via vacuum filtration. After it's been filtrated, we can dry it in the oven. Once it's been dried and the product has been created, we will have pure benzoic acid crystals and copper sulfate in filtrate solution. A typical recrystallization has an organic compound which is soluble in hot solvents and an impurity that will remain soluble in cold solution. In the second part of our experiment, we'll take a look at the melting point. The melting point of a compound is the temperature at which it changes from a solid to a liquid. It's a physical property which we often use to help us identify compounds or to check the purity of that compound. So we can use composition diagrams to help us figure out the melting points of mixtures of two different compounds. In this hypothetical graph, we have solid A and solid B. Each component has its own melting point, but when added together in mixture, they create a new melting point, the eutectic point. The eutectic point is the equilibrium point at which A and B will melt in constant ratio.
So for this mixture, their eutectic point is at
when the
60 mole percent A and 40 mole percent B. And every mixture have their own different eutectic point, right?
Yes. Right. Now we're going to take a look into our bin that we're going to use. This is our glassware. Here we have our 50 milliliter graduated cylinder, our 50 milliliter Erlenmeyer flask. This is our vacuum filtration setup. Here we have our stir bar, magnetic stir bar. We have 2 watch glasses. We have a 150 milliliter beaker. We have a spatula. And then we have a rubber bowl. Next, we're going to move on to our chemicals. Here we have our benzoic acid.
This is pure benzoic acid.
Pure benzoic acid. We have our benzoic acid and copper sulfate mix.
Which is contaminated benzoic acid.
We have our acetylene.
Acetanilide.
We have our benzamide. We have our mixtures here with the benzoic acid and benzamide, the acetylene and benzoic acid.
Acetanilide and benzoic acid.
And then we have our mixture of benzamide and
acetanilide.
And then here we have our 4 unknowns.
So now we will start first by weighing this compound, which is contaminated benzoic acid.
Now we're going to weigh 1 gram of the impure benzoic acid. So I'm going to get my weigh boat and open the window. And then I'm going to zero it out. And now I'm going to weigh out my 1 gram using my spatula.
So this benzoic acid have impurity of copper sulfate. That is why you can see this white and blue crystals. So blue is copper.
Close the window for precise weighing.
So we have 1.009 gram.
gonna get my impure benzoic acid and I'm gonna pour it into a 150 milliliter beaker. It's now time to start the recrystallization process. Here I have my impure benzoic acid, and then I have 16 milliliters of DI water, which you can get 15 to 20 milliliters. I'm gonna place it onto the heating into a hot plate. I'm gonna put in my magnetic stir bar. Then I'm gonna pour in my 16 milliliters of water. Now I'm gonna turn the heat to 120, about 120 degrees Celsius.
Yeah, here we are increasing little bit hot, but after that we will decrease the heating.
Then I'm gonna turn up my magnetic stir bar to around 200.
So now slowly heating has started, and then we'll keep monitoring how our compound is dissolving, and after 5 or 7 minutes we'll come back to check how the compound is dissolving here. So now you can see this is after 10 minutes of heating at 121 mark. Some of the solid is still there, so benzoic acid is still not dissolved completely. So I have to increase some temperature here, maybe 160. And we'll come back after some time how our solution is dissolving. So now this is after almost 17 minutes. So what I did, I heated 120 degrees Celsius for 10 minutes, 160 degrees Celsius of this plate number, heating plate number, 7 minutes, and then 180 I did for 10 minutes. So total 27 minutes. And now you can see our solution is almost homogeneous if I stop the heating. So you can see volume has reduced. This is hot, very hot. Volume is reduced, and same time benzoic acid is still crystallizing here. So you can see this is all the solids dissolve in homogeneous solution form, but same time we are getting the crystals of benzoic acid. So you can see all the crystals are forming. So now it's time to remove from the, stop the heating. So, and now remove the flask from the hot plate and cool on room temperature. So you can see it's all crystals are forming. So better remove and let it cool at room temperature to crystallize our product, and then we will come back. So now this is after 10 minutes at room temperature. So here you can see it's all crystals are inside, and now it's time to place into ice water bath. So now it's time to cool in ice water bath for 7 or 10 minutes, and then we'll come back. And now after 10 minutes in the ice water bath, it's time to vacuum filtration. So we can remove it and filtration.
So after about 5 to 10 minutes it's time to filter our crystals. And if you can see, we've got a lot going on. So to set up the vacuum filtration, you first need to clamp your flask. Then you can put the filtration device. And last but not least, the suction tube. Just goes on there. Then we turn it on. And you can take our crystals and a micro spatula and scrape them in. You can also remove our stir bar right now. And to wash out any extra product that might be left in our beaker, we can go ahead and use some ice cold water. Pour it in here. And pour it in here to wash the crystals as well. Our flask real quick, and we're just gonna rinse it one more time. Then we can go ahead and take this off.
Or just leave it for air dry for 5 minutes. Air dry.
Yeah. Next, we just
And then
out
transfer.
here onto our watch glass. After we have our product on the watch glass, we can go ahead and come into the weigh room and put it in the 2141 oven for 10 minutes. So after the 10 minutes, we can go ahead and take it out of the oven. It's important you wear either a glove or use a mitt because it can be potentially really hot. And so we take it out and we're going to let it cool to room temperature for about 10 minutes. So after our product is cooled to room temperature, it's time to finally weigh it and see how much product we've got. So the first thing to do is take a little weigh boat and tear it out with this T-button. Tearing out just basically removes the weight from what's already on the scale. Next, we can just put this in here. And we can see that we got 0.246 grams of pure product.
Now that our experiment is over, we're going to do our experiment analysis by finding the percent recovery. When finding percent recovery, we're going to use our pure benzoic acid divided by our impure benzoic acid times 100. And that'll get us our percent recovery. These are our calculations. We got 0.246 grams of pure benzoic acid, and we started with 1.009 grams of impure benzoic acid, leading to 24.38% of benzoic acid recovered. This number could be low, possibly because of some of the benzoic acid being lost during the vacuum filtration.
Or it may have too much impurity.
Or it might have had too much impurity.
So now we're going to illustrate illustrate how to find the melting range when using a melt station. The first thing you're going to do is you're going to need to get a capillary tube. These are tiny little glass tubes with an open end and a closed end. And basically how these work are you take the open end and your product once it's been out of the oven and you pack it by tapping the product in. Then you get a pretty good amount. And the next thing you have to do is take one of these glass burettes, and we want to get our product down to the bottom. And we can do this by just dropping the tube in there with the open side up. And it will fall down to the bottom. And yeah, the next thing to do would be to come over and set up our melt station. So first we can turn on our LabQuest. Okay, it was already on. And plug it in to one of the channel inputs. Then we make sure our melt station is plugged in and we go ahead and turn it on. We turn it on to about 100 degrees Celsius. Next, we take our capillary tube with a product at the bottom and we place it into one of these slots. Now we can look at our product through this glass and we can look for it to melt. When taking a melting range temperature, there are 2 points you want to observe. The first thing you want to look at is when it starts melting. That will be the first number in your melting range. The second number in your melting point range is going to be when it's completed melting. And once you have both of these numbers, you will have your melting range.
And we have to keep monitoring temperature here. So this LabQuest will tell you exact temperature, how much your temperature is increasing in the melt station.
So once our temperature reaches around 80 degrees, we're going to go ahead and raise the heat to 140 degrees Celsius. And when our LabQuest reads 110 degrees Celsius, it's going to be very important that we start paying close attention to inside of here because we are approaching benzoic acid's known melting point.
So now temperature reaches 121. At this point you have to keep looking and see if your benzoic acid or compound has started melting.
And it looks like it has started melting, and I saw it happen at about 121.6 degrees Celsius. And now I just need to wait until it's fully melted. Just finished melting at 123.7 degrees Celsius. So compared to our known melting point of 122.3 degrees Celsius for benzoic acid, our range makes sense because it does contain that number.
Okay, now the very important part of this lab is the cleaning of the glasswares. So for the cleaning of the glasswares, this is the benzoic acid and copper sulfate. So first we will rinse with acetone and then place all this here. You can rinse all the glasswares with acetone first and then your spatula as well. And now don't throw this into the sink, we will throw this into the aqueous waste. So let's go and put it there. So now here there are two containers. This is for aqueous waste and this is for organic waste. So this is our acetone, which is organic waste, so we'll place it into organic waste only, and then after that we will wash these with the soap water and then rinse it again with the acetone. So now this is the soap water. You have to add soap water in every glassware, and in this funnel as well. Then use gentle whisk to clean, and then this you can throw in this sink and rinse with water. I will say use this DI water as well. Let's clean these glasswares with soap water. And then rinse with DI water. So this is typically we do for every glasswares, and once we're done, we have to rinse it again with the acetone. So now they are all clean with the soap water. We have to rinse again with acetone, and now this will be dry. Let it keep like this one. And now we will throw this again in organic waste, and after that we can keep it in our bin.